Good morning, Year 11s. Welcome to the step beyond quadratics that is polynomials, where we start generalizing what we learned in quadratics. Good news is anything that worked in quadratics essentially works with polynomials as well. Now, there's a big scary notes on the page, but basically what it's saying, a polynomial looks like p to the x equals a to the n, x to the n. A minus 1, x minus 1. Essentially, it's just like an extended quadratic where you might have a 3x to the 4 at the start, then an x cubed, an x, and an x to the minus 5. So note here they could have put an x squared in there, that would have been fine. And to start off with, there's just some terminology you need to know. X is the variable. So here are all the variables. There, etc. So that's not too bad. The constant term is the one that typically hangs on the end, but note it's not always on the end. They enjoy tricking you. The constant term is the one that is not multiplied by any x term. So in our case here, it's the minus 5. Now, it's entirely possible they could have put a minus 5 in there, and it would still be the constant term. The leading coefficient is the coefficient of the x term with the highest power. Traditionally, it goes at the front, hence leading. So 3 here is our leading coefficient, but note if they'd written a 4x to the 5 in there, then the leading coefficient would be the 4, because it's the coefficient of the term with the highest power. Degree is the highest power, so this is a degree 4. And you can be asked to find the coefficient of x squared, for example. Here, in our example, the coefficient of x squared is 0. The coefficient of x cubed is minus 1. Alright. So, you've seen some of these already. Degree 1 and 2, a linear quadratic, cubic, quartic. Others where you're looking at. Although it can be useful to generalize beyond this. So, looking at, not that, GeoGebra, this here is a linear. 2x plus 1, you've seen linears before. Now note, linear has a power of 1, which is an odd power, and it goes from down here to up there. I hope you can see my cursor. Now look at x squared. X squared is even power, up to up. A cubic. Note how the cubic, odd, follows the pattern of the linear in that this is first quadrant and third quadrant. At extremes, that's where it goes. Sure, it wobbles a bit in the middle, but at the extremes, it goes towards the end. Note the even. The brown is the quartic. Sure, it wobbles, but in the end, it does exactly what the quadratic does. And this pattern sort of continues. X to the 5, x to the 6. Essentially, even powers will eventually make things positive, making it go like that. Or if the coefficient of the even powers is negative, you'll have a polynomial that goes like that. Odd powers are always this sort of dance move or that one, depending on the sign at the front. And you'll start spotting these patterns as you work more with them. Alright, so polynomial equality. We can say and solve some quite cool equations this way. If you have any polynomial written out, ooh, I really hope that's still recording, guys. Sorry, having struggles with video. If you have a polynomial written out like this, then you can what's called equate coefficients. You can say, well, here A must be 2, B must be 3, C must be minus 4, etc. D must be there. Alright, and that leads to this sort of question. So, solve this for all x. Alright, well, this here is an x squared. Over here, well, what's the coefficient of x squared? Because remember, the coefficients must be the same. The coefficient of x squared here is 0. So that means that a take 2 must be 0. The coefficients must be the same. Here is a coefficient of x. The coefficient of x must be 7. A plus b equals 7. And note here how this starts bringing up simultaneous equations from previous years. So you should be comfortable solving this type of thing. This one is ridiculously easy in that you get a equals 2 from there. and that then gives you b equals 5. But you can understand how they might get more tricky. Alright. The obvious trap there would be not to see that's x squared. Okay, going down. A little harder. This here is a cubic. And this here is a linear and a quadratic. And it's interesting to note that a linear and a quadratic is how you break up a cubic, and it's how we're going to work towards factorizing polynomials in the next video. So here we're asked to work out what a, b, c, and k are. Alright. Some of these are really easy. And that normally comes from imagining how this expansion would go. So if we were going to expand this out, we would expand that out, and that would get us 5ax cubed. And that's the only way we would get an x cubed term, is by doing the x term here multiplied by the x squared term. That's the only x cubed term that's coming out of this expansion. Therefore, we can say that a equals 1, because it must be equal to the 5 there is 5a. The other easy one that falls out is normally the constant term, because that is the only way we get a constant, is the two constants multiplying. 2c is equal to minus 6, therefore c is equal to minus 3. Alright, not too bad. Alright, so we've knocked out the easy ones. The easy ones are usually the leading coefficient of the constant. Now let's try and rewrite this and see what it looks like. 5x plus 2 bracket x squared, because a is 1, plus bx, take 3. Alright, not too bad. Now let's expand that out the long way. So 5x squared, and remember, expanding this out the long way just means that each of these goes to each of the others. It's like an epic foil, and you should expect 6 terms at the end. 5x squared plus 5b cubed, x squared minus 15x. Now the 2 comes in, plus 2x squared plus 2bx minus 6. Alright, now I would collect the like terms together. 5x cubed, there's nothing like to it, plus 5bx squared plus 2x squared minus 15x plus 2bx minus 6. So note how I've grouped the x squared terms together, and I've grouped the x terms together. And that means that the highlighted coefficients here, 5b plus 2, must equal to k. Similarly, the minus 15 plus 2b must equal to minus 7. So the coefficients of x and the coefficients of x squared must line up, and that gives us our next set of equations. So we can write minus 15 plus 2b equals minus 7. And if you're not sure where that's come from, think about taking the entire thing involving x. You could have minus 15, x plus 2bx equals minus 7x. And then at this stage, you just divide by x, and the x disappears, and you're down here. Alright, so let's solve for 7. Add 15 to both sides, which means 2b is equal to minus 7 plus 15 is positive 8. B is equal to 4. Nice, b is equal to 4, and now we need to find k. So what we're down here is we've got 5 times 4 is 20, plus 2 equals k. 20 plus 2 is k. K is clearly 22. And that's all of our variables. And I realize that example is quite a hard one, but the important thing is you're able to pick off easy ones to start with, expand out, and pick off equations that we can then find useful to solve. Alright, I hope that's given you some idea of the language surrounding polynomials and a couple of examples to do with polynomial equality. Thank you very much.